This is a Cartesian diver. When I squeeze the bottle, the diver sinks, and when I release, it floats back up again. This is just an old soft drink bottle filled with water, and the diver inside is just an old pen lid filled with air and being weighted down by paper clips and masking tape. But why does it work? Well, the reason why was first published by Robert Boyle in 1662.
Boyle used a closed J-shaped tube. He poured mercury into the open end and forced the air in the closed end to compress under the pressure exerted by the mercury. Notice that at equilibrium, the pressure of the compressed gas must be exactly equal to the pressure exerted by the mercury plus the pressure exerted by the atmosphere, else there would be movement in the tube. Boyle found that the amount by which the gas in the closed end compressed was directly proportional to the amount of mercury added. Because the amount of mercury added was directly proportional to the additional pressure on the gas in the closed end, by the formula pressure equals ρgh, Boyle could conclude that the volume of a gas was inversely proportional to its pressure, or, in other words, V is proportional to 1 on P. Pressure is just a measure of the number of collisions which gas particles have with the walls of their container per unit time, and so intuitively this law makes sense. If the volume of a container within which a gas is stored is increased, then the number of collisions with the walls of the container per unit time will decrease, and hence so too will the pressure. In the case of the Cartesian diver, squeezing the bottle exerts a force on the pocket of air in the pen lid, causing it to compress as given by Boyle's law. Because the buoyant force on the diver is directly proportional to the density of the air in the cap, the buoyant force on the diver decreases as the pressure exerted increases. At a certain point, the buoyant force is too weak to hold the diver up, and the diver is accelerated down by gravitational forces. When the pressure exerted on the bottle is released, the gas expands, the buoyant force increases, and hence the diver floats back up. Suppose the volume of a cylinder in a car engine is at maximum 3.4 litres and at minimum 0.5 litres. Then suppose that immediately after igniting the fuel in the cylinder, at minimum volume, the pressure of the exploding gas is 200 kilopascals. What is the pressure of the same gas once the cylinder reaches its maximum volume, assuming there's no change in temperature? We know that the initial volume is equal to 0.5 litres, the initial pressure is equal to 200 kilopascals, and the final volume is equal to 3.4 litres. We also know from Boyle's law that the initial pressure multiplied by the initial volume is equal to the final pressure multiplied by the final volume, and therefore the final pressure is equal to the initial pressure multiplied by the initial volume divided by the final volume. Substituting in values, we get that the final pressure is equal to 30 kilopascals.
Boyle is largely regarded as the first modern chemist and a pioneer of the scientific method. He also discovered or investigated sound waves, the expansion of water when frozen, specific gravity of liquids, refractive power, electricity, colour, crystals, and the field of hydrostatics. Boy did Boyle make a great contribution to science. Bye!